Okay, we're going to talk about future value of an annuity. So we did talk about annuities in the last lesson, and what we're going to talk about today is actually doing some questions. So remember we said an annuity was like an investment account where we had compound interest that was calculated, but it's where we're making a regular contribution to this account. We did talk about some examples in the last lesson where that contribution may be paid out of the account. So we may be a self-funded retiree was the example we talked about. But it's basically an investment account, which we know real life investment accounts use compound interest, where we are having a regular contribution. So we talked about the compound interest formula, and we said that A was in the compound interest formula stood for the amount. So that was the amount that it would be worth in a certain period of time. The same A stands for the same thing in the future value of an annuity. So I'm using FV only to stand for the future value instead of me just writing it. But FV isn't the convention, they just use A. M, capital M, is the contribution per period, and it's usually paid, for this particular type of annuity formula, it's paid at the end of the period. So N is the number of compounds, or the number of periods in total, and R is the rate per period, and as we talked about last lesson also, it needs to be as a decimal, and if this is a lengthy number, we need to make sure we input it into our calculator using one of those storage methods. Now the formula for the future value of an annuity is on your formula sheet, and here it is here, and you won't need to copy it off, but you'll need to make sure you're using this formula sheet. So A, the amount, is the contribution multiplied by big brackets, small brackets on the top, 1 plus R to the power of N minus 1 over R. Another way of talking about an annuity is a sinking fund. Now, we talked about the same sort of thing last lesson, but we didn't actually call it a sinking fund. So this is where the future value, or the amount, is decided, and then we need to work out the regular contributions that we must pay in order to reach this target. So let's say, for example, I knew that I needed to have $20,000 for my child to go to university, and I know that's going to be coming up in 15 years' time, then I will make sure that I will put the right amount of contribution in at the end of each month to ensure that I get that money for my child to go to university in the length of time. So let's do two examples of something that's almost identical that we've just talked about. So the first one is an example where we've got just an annuity. So Dean and Sam have an account at 10% per annum. They deposit $10,000 at the end of each year for 4 years. So nice and simple, no dividing up for compounds or no dividing up for interest rate. So we want to find the future value, or the A, the amount, and we want to find the amount of interest that we've earned. So writing down your future value formula, directly coming straight from your formula sheet, A equals capital M, etc., etc. Writing your letters down the side, just what we would do with compound interest. So A equals, R equals 0.10. Remember, it's 10%, so it's got to go as a decimal. N is 4 because it's only going in every year for 4 years, so there's no dividing or multiplying. And M is 10,000, the contribution. We are depositing $10,000 at the end of each year. So writing out your formula and then substituting into this formula, we're getting 46,410. If I then wanted to find the interest earned, well then I need to work out, I've then multiplied, so my interest is 46,410 minus, for 4 years, I've deposited $10,000, and how much extra, so that's 40,000, so I basically have earned extra, is what my interest is, $6,410. When you're doing these and you're inputting them, you do it all in one step, from this step forward, all in one go. This we don't have to do any ... because it rounded off nicely. But make sure you are very careful with your brackets. If you open a bracket, make sure you close the bracket, otherwise you'll get a syntax error on your calculator. Make sure you read what you've typed into your calculator. Use the replay button to go back, and make sure that you then understand exactly what it is that you've typed in. Go backwards and then double check that what you have typed is what you have written. Okay, the owners of a block of units estimate that they'll need $20,000 in 4 years' time to repaint their unit block. They open a fund at 6% per annum, which is compounded quarterly. And what we need to know is how much must be deposited at each quarter. So we're trying to find the contribution. $20,000, again, sorry, our formula off our formula sheet. The amount is $20,000. That's how much we want this annuity to be worth in 4 years' time. The interest rate is 6% as a decimal, 0.06. We're dividing it by 4, and I'm going to put it into my calculator as part A. So 0.06 divided by 4, even though it gives me a nice, reasonably nice decimal, I'm then going to store it. So remember, I'm now going to press AC. Then I need to use my store button. So Shift, Store. See that STO comes up. Actually, sorry. Answer, Shift, Store. See that the STO comes up, and then I'm storing it in A. Now when I'm referring to it, I'm showing exactly in my solutions that I'm going to make it A. So when I substitute into my formula, I now can replace my R with the letter A, and I know I'm going to use exactly that from my calculator. 4 years, but it's compounded quarterly. There is 4 quarters in each year. 4 times 4 is 16, and the contribution M is what I'm trying to find. So in this case, I'm substituting in. I'm not substituting in for my rate. I'm substituting A in place of that. And what I will get is I need to get this bracket as an answer. So I'm getting 17.32932 ... In order to get M by itself, I simply need to divide both sides by it. So 20,000 divided by answer, and that will give me $1,115.301 ... and therefore that's going to be my contribution. So what I need to contribute, or what must be deposited, therefore $1,115.30 must be deposited each quarter in order to reach $20,000. You can now work on exercise 802, and you can work on questions 7 through to 12.